Alrighty then. Algebra half, lesson 115, page 358. Now there's a bunch of stuff on here. I am not going to draw on the board because I don't want to. You need to look at page 358, page 359 for me. Polygons. Polygons. On page 358, and I think you all know this stuff to some degree. The name of the polygon is an object with all straight sides. It's a closed object with all straight sides, no curves in it. Okay, so first up there on the very top of the page, that thing, you can find the area of that, but it's not a polygon because it's got a curve. B is not a polygon because it's not closed. C is a concave polygon, and we're not going to do a lot with those. D is a convex polygon. That means anytime you draw a line from any vertex to another vertex, it never goes outside of the object. Don't worry too much about that, but kind of keep those in the back of your brain, about right there. Okay, so if you have 3 sides, it is called a triangle. Okay, if you have 4 sides, it's a quadrilateral. If you have 5 sides, it's a pentagon. 6 sides, it's a hexagon. You've got to get that 6 down. 7 is a heptagon. 8 would be an octagon. 9 would be a nonagon. Be careful of that one because there's another one called an inagon, means it just has n number of sides. But a nonagon is 9, decagon 10. I can't even say that, 11. I really can't. Undecagon, I don't know, that's retarded. Nobody ever says that. And dodecagon is 12, duodecagon is 20, just stuff, okay? Next one is the word regular. The word regular in math is a very specific meaning, okay? It doesn't mean that you go to the bathroom at the same time every day. Regular means that the lengths of the sides and the angles within the object are the same all the way around. So if I have a regular triangle, the sides are all the same length, angles are all the same, that's called an equilateral triangle. And that means that each angle is 60 degrees because 60 plus 60 plus 60 is 180. This is a regular triangle. A regular quadrilateral, that means it has 4 sides, they're all the same, and all the angles are the same, they're all 90. That's a square. Okay? A rectangle is not a regular quadrilateral. It's a rectangle. The sides aren't all the same. There's a bunch of different kinds of quadrilaterals. There's trapezoids, there's kites, there's trapeziums, there's rectangles, there's rhombus. But the only one that is regular is a square. Okay? A regular pentagon has all the sides the same. Ooh, that's not even going to be close. All the sides are going to be the same length, and I'm not drawing that very well. But in our imagination, all the sides are the same length, all the angles are the same, and then we know things about it because it's regular. So if you see that word regular, it's very, very, very important. Okay, regular. Down on the bottom of page 359, they name a bunch of different kinds of rectangles. Trapezoid, 2 sides parallel, parallelogram. Opposite sides are parallel, rectangle. Opposite sides are parallel. Opposite sides are equal and all 90 degrees. A rhombus just has all 4 sides the same, but not necessarily the angles the same. Have a square, that's a regular. They don't show it, but there's another one called a kite. A kite has a very specific shape. It looks like this, where this side are equal, congruent. This side and this side are congruent. These 2 angles are congruent, but these 2 are not. Okay, but this is a specific kind of quadrilateral. You won't deal with that until next year, probably. Or unless you watch Mary Poppins and you go fly a kite. Now, the part that's a little bit more fun here is on the practice there, you have to name each one. Let's see, what does it say? Give as many names as you can for each one of these figures. Okay, as many names as you can. A. Now I'm going to give you 8. Now listen to this. Number 1, how many sides does it have? 4. Therefore, it's a quadrilateral. Number 2, are opposite sides congruent? The answer is yes. It is a parallelogram. Technically, it's all those things. It has 2 parallel sides. It has two pairs of parallel sides. It is a rectangle because it has opposite sides are congruent and 90 degrees. And it is a rhombus because all the sides are the same, and it's a square. Okay, so you use all those words for it. Use as many of the words as you can. Okay, down there on G, all you know about that is how many sides it has, right? It has 1, 2, 3, 4, 5, 6 sides, so therefore it is a what? Okay, it's a hexagon, and it is also what kind of hexagon? It has that little indentation over there where somebody ran into it with a Volvo. Okay, it is a concave hexagon. It wasn't really a Volvo, it just looks like it, okay? Now, this next part is transformation. We're going to transform, we're going to move things around. The first one here is translation. To translate is to move left or right and or up or down. Okay, so I can translate this down, I can translate it here, I can translate it here, I can translate it both. I could go right 3 and down 4. This is translation. You move it. It never changes its orientation. It's always going to look like that. Here, we're just going to move it to different places. That's translation. Rotation is when you spin it around a point. It would be like if we nailed this to the board right there, and we just move it around. Okay? If we moved it 90 degrees, this would be right here, and it would look like this. We'd move it, or we'd rotate it, and that's actually 90 degrees. If you rotated it again, you'd have this piece here. This would come down here. We'd have this. You rotate it again. Okay, if we rotate it again, it would be right here, like this. We'd rotate it again. This is rotation around a point. Now, you got to be careful. You could rotate it around this point. You could rotate it around this point. You could rotate it around this point, or you could rotate it around some point out here. And that gets a little bit more difficult. If we had it on a graph and it was sitting like right here, and we rotated around the origin, we would take this here and we would move it, the whole thing like that. Does that make a little bit of sense? This is the point we're rotating it around. Okay, that takes a little bit of work. They don't actually ask you to do that. They asked you to do that last year in the 7th grade, but not this year because you're smarter and they know they can't fool you. Okay, reflection is like when you look in a mirror. And I know that, well, let's see, who's in here? This is Generis Jarellis. It's Leanne, it's Kaylee, and it's Ethan. So I know that all of you spend a lot of time in front of the mirror because you're beautiful and you want to make sure that you are. But when you look in the mirror, what you're not seeing is actually yourself. You're seeing a reflection. So a reflection, the other word for reflection is you flip it over. Okay, if we're going to reflex. If we're going to reflect it over this line, it's going to come over here like this. That is a reflection. If I reflected it over this line, it would just, if you look at it, think like this. You take it and you're going to reflect it over. So it's going to come down here like this. Does that make sense? We could reflect it up to here. Okay, we could reflect it down to here. We can reflect it. That is to flip it over a line. So translation is just moving it left, down, up, right. Rotation is spinning it clockwise, counterclockwise. I know you guys don't like that because digital clocks don't do that. Reflection is just to flip it over, but you have to understand what they're flipping it over. It says if it's reflected over the y-axis, that's the y-axis, kiddos. That is reflected over the y-axis. That's reflected back. The x-axis is right here. I can reflect it over the x-axis. I can reflect it back. I can reflect it over the x-axis, and then here, reflect it over the y-axis, and I'd end up over here. Okay, I reflect it over the x-axis, reflect it over the y-axis. All right, it's the same triangle, but it's just moved around.